Hey, Dr. Mike here. Understanding the importance of nutrient absorption is key to supplementation. Stay tuned to find out more about it with our expert guest.
You're listening to Live Foreverish, a show dedicated to helping you live just a little longer. Here's your hosts, Dr. Mike and Dr. Crystal Gossard.
All right, welcome to Live Foreverish. So, Dr. Crystal, I'm really happy we're finally talking about this with an actual expert that can explain all of this stuff about absorption, et cetera, today. Because you and I, we talk about food first a lot.
Absolutely.
Right, and that's key. But then we explain the need for supplementation, right?
Right.
To fill in those nutrient gaps, talk about more optimal levels. And then people start questioning, well, how do I know everything's absorbing?
How is it getting? What if it's going out the other way immediately?
Yeah. Of course, they never question the food sources.
That is very true. No one thinks that if I eat this apple, is it all getting into the body?
Yeah. And so,
but maybe not.
Maybe not. But we are going to focus on the supplementation and the way we formulate and why thinking about absorption is key. So we have a special guest. Her name is Dr. Cristina Matthewman. She's the Innovation Team Leader in Research and Product Development at our sponsor, Life Extension. She's earned a master's in Biophysics and Medical Physics from the University of Bucharest and a PhD in Neuroscience from the Miller School of Medicine here at University of Miami. Dr. Cristina, welcome to the show.
So glad to be here. Thank you for having me.
Yeah, it's exciting. We love having experts, so Crystal and I aren't saying things we probably shouldn't say. So one of the reasons we're bringing you on is you co-authored a review article that was published this year, right? I think 2023.
2023.
Right? Yeah. And in that, you kind of brought to light, like the limitations to how it's not just nutrients, how drugs, nutrients kind of get in and move throughout the body, and it's something we call pharmacokinetics, right? So tell us a little bit kind of about the article, more about like why you felt this had to be written. We don't need to go through the details of the article, we'll talk about it, but just why was this important for you to write? And then kind of give us a general explanation about absorption.
So that's a very interesting topic for me. I worked on that specific formulation, and it was important for us to better understand all the limitations with curcumin in particular. Is very poorly absorbed, and it has a lot of science behind it, this formulation that was specifically developed to overcome all of these limitations. And not only that, the review also summarizes all the preclinical and clinical work with this formulation.
Yeah.
And it's been quite a work. But
so you bring up curcumin, and you're using that as kind of the example of the absorption issue and stuff, which is great because it doesn't take a lot of research to know curcumin. I mean, how many clinical studies have shown efficacy with curcumin? I mean, hundreds over the last decade probably, right? But again, if you can't get it in your body, you're not going to really benefit all that much, right, Dr. Crystal?
That's right. So in the article, and I read through it, and bravo,
thank you.
because it's something that we've talked about a lot as nutritionists, but I think the public awareness of the topic needs clarity. The public needs clarity on it. So can we start with absorption? I like how you kind of started with that in the paper, and I think that lays a good foundation for our listeners on what's really happening with absorption.
Absolutely. Dr. Crystal, this is like a very important question. I've seen the term misused even in the literature, in the field. Not even the experts, not only the public. So when we talk about an oral formulation, absorption is defined really as that movement across the epithelial cells in the digestive tract into the bloodstream. So I like to think of it as that first step in the journey of the drug through the body. And this absorption really involves the transport across several cell membranes. And cell membranes are like fascinating. It's a passion of mine.
She's a true
but
scientist.
Yes,
Audience.
yes.
True
They
scientist
are
here.
they are by design, right, a barrier to outside world. It's not just that structural integrity, but it also protects us from everything that should not go
Right.
inside our bodies. And that's good and bad, because it also is semi-permeable to the good stuff as well. But the good part is that there are specialized mechanisms that allow transport of the nutrients and vitamins and all the good stuff that need to go in. So some of those main mechanisms of absorption are either by diffusion, which can be passive or active, and that doesn't involve energy, and it usually goes across a concentration gradient from a high concentration to a low concentration, and also active transport, and that it involves more specialized proteins like pumps and ion channels that require energy and can also do the job of transporting against that concentration gradient.
So you mentioned these different ways of getting through, right?
Yeah.
So when you're formulating a product, right, or making a formulation for like curcumin, let's just use curcumin as the base example here, right?
Right.
You have to start thinking, well, how is this going to get in? What process is it using
Exactly.
to cross? And so there's limitations there, but then I would assume things happen to the active ingredient just being in the stomach, just being in the small bowel. So what are some of those limitations you have to kind of anticipate to make sure we get enough curcumin in?
It's another great point, and that's one of the main limitations, especially with oral formulations, are right that the oral formula has to survive. Your stomach is a very acidic pH, and not only that, but also digestive and microbial enzymes that can transform that active component, that can conjugate it, make it into an inactive form that gets eliminated and doesn't get absorbed in the body. And so it's just the nature of the cellular membrane as well. That's a lipid bilayer. So it's by nature hydrophobic, and it doesn't allow charged particles to get through, like you think about your calcium absorption and so on. So it's not just the cellular membrane, but also the properties of the drug itself or the formulation. Its solubility, its size. We talked about the charge, like most of these substances, when they get in solution, they become charged and polarized molecules that do not get, cannot freely permeate through the membrane anymore.
Yeah. Well, you wanted to talk before we get into kind of the specifics of what you did with curcumin and basically the reason you wrote this article, right? Bioavailability, right?
Yes. That's a concept that you talked about in the paper. And you highlight that bioavailability is different from absorption. So can you explain the difference between the two?
Right. So bioavailability is, by definition, is that fraction of the ingested drugs that reaches the site of action in the body in its unchanged active form. And that takes into account not only that absorption, that first step, but also the distribution through the body and the clearance rate. Like that includes your metabolism by the liver and also evacuation, elimination from the body. So that excretion. In pharmacokinetic studies, for instance, this is parameter, the bioavailability is calculated as that area under the plasma concentration versus time curve, or AUC, and is typically relative to the same process for the unformulated form.
Yeah.
And something you just stated stood out to me was in its unchanged form.
Yes.
So if you're taking, let's stick to curcumin, for example, curcumin in its unchanged form, because after the absorption, then it goes to the liver and then it's transformed, or some of it is transformed. So are we talking about the amount after all of those transformations take place, that same curcumin, how much of that is actually getting into the tissue?
That's spot on. I'm glad you picked up on that. It's like the most important to have adequate, sufficient amounts of the active forms of anything, any substance at the site of action in order to have some biological effect.
Yeah.
And in the case of curcumin, it was shown, like several studies have shown, that the conjugated form, like curcumin monoglucuronide, is actually 10 times more antioxidant, has less antioxidant activity, less anti-inflammatory activity than its conjugated counterpart. And that's been shown with other phenolic compounds that are notoriously low bioavailable as well, such as quercetin.
Yeah.
In a recent animal model of hypertension, when the deconjugation is blocked in this animal, so the free quercetin is not available, quercetin intake doesn't lower blood pressure. So that's super important. And
I just want to back it up, just make sure we're following this, right? So every step along the way so you have this compound you want, curcumin. We want that. That's what we want, right?
yeah,
In a sense, we call that free active curcumin.
exactly.
But every step along the way, right, it comes through the gut, right, into the blood. You lose some there. It goes through the liver. You lose some there. You then even mentioned this idea of conjugation. If I may, and you can please correct me if I'm wrong. That's basically where things attach to that free active form, making it maybe a little less effective. And so at the end of the day, that free curcumin is pretty low from where it started when you swallowed it. Is that kind of the idea?
In the case of, again, absolutely true. In the case of curcumin, it's 1% bioavailability for free with the unformulated. So it's very poorly.
1%?
1%.
So if someone does just a regular good old fashioned curcumin from turmeric, little thing in a capsule,
that's why you see those
1%.
doses are pretty high.
That was what I was going to
That's how you kind
say.
of overcome. Just start shoving a whole bunch in there.
Right, because the research shows curcumin works even, in unformulated, but the doses are
Typically high.
really high, and something that you mentioned, it still has an effect, but not as effective as the free version of the curcumin, the actual compound that you're putting in your body.
So that idea is correct. There's some activity from conjugated and metabolites as well as some potential effect on microbiota, on the actual gut microbes itself that can produce further metabolites of their own. But mainly the free active forms in all the studies I've seen, they seem to have the higher biological effect.
Yeah, so this makes me, I'm starting to think now. Yeah, I can think.
Okay.
She just kind of looked at me funny. So we started all this by saying there's been hundreds, right, of curcumin studies throughout the years, and they've shown some good efficacy in inflammatory conditions, as an example, even cognition. But in those studies, they're probably using just regular old curcumin. I mean, so what we're saying is if we can figure out how to get more free curcumin in the system, we might actually even enhance some of those results. Am I on kind of the right track?
So in the case of the special formulation, it was tested in the studies with the unformulated curcumin. There's also historical now, a lot of strategies have been used to improve bioavailability of curcumin and other compounds. And in the case of this formulation, it was compared in the study with the unformulated curcumin, and it was always more effective and always at the lower dose.
So what did you actually do to curcumin? I mean, like, okay, so you've improved on, at the end of the day, what you've done is you've allowed now more free, active curcumin
Exactly.
to get to the cells where we want it. How, so was
So-
it some magic?
We are magicians, but this was using a patented technology that is a water-only based process that combines the curcuminoids from curcumin formulation with a homogeneous gel phase of the fenugreek galactomannan fiber. I'll make this simple
Yeah,
for
Okay.
you.
Yes.
So these curcuminoids are effectively encapsulated in a hydrogel-like structure that hydrophobic pockets are produced by these fibers, so that protects the curcuminoids from degradation from intestinal enzymes. And also it allows this complex to stick around longer in the intestine to improve that absorption.
Okay. Yeah.
So it's like a scaffolding
Yeah.
for
Little
the
little
curcumin.
pod or some little
Exactly.
submarine that surrounds the
With the air
curcumin.
pocket in the middle.
And what about conjugation that has? So does it also decrease some of the conjugation that you see?
exactly it protects these curcuminoids from getting the enzymes attacking them.
Yeah. And so when you did this, right, when you made this formula, I mean, what were the results? Like
Yeah, that was-
what's the conclusion? What did you find out? How much more free curcumin are we seeing?
In the clinical human study that was done, comparing with the unformulated curcumin, it was 45 up to 45% fold increase in bioavailability. So that's pretty impressive, even compared to other formulations. And it did measure free curcumin. Some of the challenges in the field were in some of the methods that are used by other formulations, in where they pre-treat the plasma samples with an enzymatic treatment that kind of artificially freeze the curcuminoids. So what you measure in the actual AUC would not be the true measurement of free curcuminoids. In order to do that, you would have to compare that value before enzymatic treatment with after enzymatic treatment. That would give you the true value of the free curcuminoids, the true amount.
Now, in the clinical study that you're referencing, did they evaluate any clinical outcomes, or was it just kind of focused on the bioavailability at this point?
Absolutely. There's 3 bioavailability studies, but also more than 10 clinical studies. I think there's 12.
Oh,
And
nice.
some more in the works. So there's a lot of research with the curcumin formulation with fenugreek, and that, including safety, measures of brain health. We know that it was studied in humans, given to people, and they looked at with electroencephalography. It showed increase in brain waves, so that suggesting that the compound actually crosses the blood-brain barrier. And we know that it does from the animal studies in which they actually measured it. But the human, obviously, we cannot dissect people's brains, so that's a surrogate for a measurement for blood-brain permeability.
Yeah.
So that was cool. And also liver health, cardiovascular parameters that will measure anti-inflammatory, lowering, effect on lipid profile, and joint health as well.
I love it. 'Cause
Wow.
we talk often about like a core foundation of nutrients that people need, and curcumin is kind of right up there, right? Where it's not always in our top, but it's like wants to be in the top. It sounds like maybe we need to move it into the foundation, Dr. Crystal. So this whole fenugreek glucomannan scaffolding thing, is this going to be applied to other nutrients now, or is it really just a curcumin thing?
You are a pioneer thinker. Yes, I like it. And that's what the company providing this technology has successfully applied it further to other notorious phenolic compounds that have poor bioavailability, including fisetin, quercetin, and probably more
Yeah.
in the works.
So it's exciting.
That's
With
exciting.
slight tweaks of the formulation, obviously, but the idea is the same, like providing that protection and improved bioavailability through the scaffolding of the fiber from the fenugreek.
Yeah. And I hope, I mean, this is important stuff, right?
Yes.
It's, people who are really into filling in that nutritional gap, looking at different nutrients to do that, not just food, right? We talked about that. Understanding all this and being able to be a good consumer, right? And know what to look for.
Yeah.
To make sure, number one, that you're getting your money's worth, right?
Very
and that what you're
true.
taking is actually getting to the cells that where we need it to be, right? So this
Absolutely.
is fabulous.
That's what
Where
we
can
hope.
our audience learn a little bit more about some of the stuff you formulate?
A very good resource is always our website, lifeextension.com, where they can find further details and references to all these studies and the technology as well. And other PubMed.
That's the scientist.
I
in her.
think
yes.
That's the scientist.
I think Life Extension does a better job of translating that scientific, technical
Yeah.
language into a more consumer-friendlier
Yeah.
language.
Yeah, at the end of
So,
the day, people have to understand.
yes,
If they don't
right.
understand, they're not going to listen, right? That's
Absolutely.
great. Dr. Cristina, thank you so much for it was fascinating work, number one, and just so happy that you came on kind of helping us and our audience just get a better handle of all these words they hear, like absorption and bioavailability and free forms and active. So again, thank you for coming on.
absolutely. It was a pleasure. Thanks for having me.
So you can go to liveforeverish.com where you can download more of our episodes, right? When you're there, Dr. Crystal, 404. I'm actually making that up. It's close.
Oh, goodness.
It's like 403. I keep forgetting. It's
I'm
the
not
problem.
sure, but 2 a week.
2 a week, and we were
Yes.
at 400 like a month ago.
Wow.
So
Yeah.
Bravo.
There's a lot there. And when you do, please go ahead and download, like, and share. We love to hear from you. And, of course, subscribe so you never miss a show. It's the 1-2 punch. You can give your email, and you'll receive newsletters from our sponsor, Life Extension. And then you can subscribe to your favorite podcast service right there. That's liveforeverish.com. I'm Dr. Mike. That's Dr. Crystal. Thanks for listening.